Welcome to Chapter 7. This is randomness, probability, and simulation. Alright, so if Mr. Jones has the thumbtacks today, you can pause the video after you read the instructions and you can try this. What you're basically going to do is see if flipping a thumbtack is the same probability of getting heads and tails. So what you're going to do is flip a thumbtack 50 times and keep track of what you find. If you have the sharp point up, you're going to put a U, and if the sharp point is actually touching the carpet or the ground, you're going to put a D. And so you can make those two columns, and as you flip the thumbtack, just keep tallies and see which one is more likely to occur. So in this chapter, Chapter 7, we start getting into some heavy math. We're going to do a lot of probability study now. So we're going to talk a little bit about this before we get into some heavy math. First of all, something is random if an individual outcome is uncertain. But after a large amount of repetitions, we can usually see a pattern or a distribution that starts to form. For example, flipping a coin, you don't know exactly what's going to happen unless you cheat. But after a while, you can start to see that it's going to be about 50-50 if the coin is fair. Probability is any outcome of a random phenomenon that will be a number between 0 and 1, or if you change it to a percent, it would be between 0 and 100%. Remember to change a number to a decimal or a number to a percent. You just move the decimal 2 places to the right. So if I go between 0 and 1 and 0 and 100%, those mean the same thing. It's going to describe the proportion of times the outcomes occur after a long series of repetitions. So remember, if you flip a coin twice, it's not going to necessarily be heads and tails, because that would be perfectly 50%. You may very well get 2 heads or 2 tails. But after 100 or 1,000 or 1,000,000 times of flipping the coin, you would expect to see about 50% of each. If we say the probability is 0, we are saying that it will never occur. And when we say a probability of 1, it is certain to occur. When I lived in South Florida, I checked the weather. It said 0% chance of rain, and it was raining outside. So apparently they did not know what 0% meant. So probability, as you could probably guess, was based on gambling. So gamblers started noticing patterns when they started playing games, and then French gamblers asked mathematicians to kind of help them cheat or figure out a fair way to bet on games. So probability theory studied the mathematical study of randomness, and this was started by Fermat and Pascal. So here's a good matching question. I want you to match the probability below with what you think each statement would be. So number 1, or number A, or letter A, the probability of rolling a 9 on a dice. Well, if you look at a dice, it goes 1 through 6. So there's no way you can get a 9, so that would be the 0. The probability of rolling a dice and getting a side with at least 1 dot on it. Well, all of the dice have at least 1 dot on it, so that should be 100%, or the 1. This event is unlikely, but it will occur every once in a while. That could maybe be like 30%, or that 0.3. And the reason why I didn't pick the other number is because of D. This event is very unlikely. It will rarely occur. That would be 0.01, or basically 1%. And this event will occur more often than not. Those answers could be 99% or 60%, because both of those are over half, so we would assume that they would occur more often than not. So probability is something that most students are most comfortable with when we start talking about it, because most people know about chance of rain and the chance of getting something in a vending machine, or a game of chance, or different things like that. So a lot of students have some comfortableness with probability. However, as you could probably imagine, there's a lot of myths or misunderstandings about probability. So you need to make sure that you write down the names of all of these myths and you know exactly what they're saying, because it'll be on your homework and it'll be on your quiz and test. So the first myth we're going to talk about is the myth of short run regularity. We know that randomness is predictable in a long run, but people tend to think that random phenomenon should also be predictable in the short run. So basically what they're saying is, after 2 flips of a coin, you really should have heads and tails. But that's a myth. You know that that's not true. So look at the 2 choices below. Those are heads and tails. And they say, if we flip a coin 10 times or 6 times, which outcome is more likely to happen? To get a head, then a tail, then a head, then tail, tail, then a head. Or to get 3 tails in a row and then 3 heads in a row. Actually, if you sat down and calculated the math, both are actually equally likely to occur. There's nothing magical just because the first one was more mixed up. However, because we see that pattern in the second one, something in our brain says, oh, that can't be right. That must be more rare to happen. So that myth of short run regularity is saying, look, either one of those combinations, because it's 3 tails and 3 heads, it's just in different orders, are both equally likely to occur. Some people believe in a hot streak in basketball. So you could be hitting several shots, and we tend to think that they're more likely to hit the next shot. However, it really is just the basis of how good they are. So some days they hit a lot, and then they don't hit some, and then the other days they start off bad, and so they think they're doing bad, and so then it becomes like a self-fulfilling prophecy, and they don't try as hard. So really, those hot streaks that people think they're on is really just they started off hitting them in, so they kind of believe that they're going to make it in, but it's really not a probability thing. All right, so the second law you should write down and make sure you understand where it is and when it's used is the myth of law of averages. The myth is where one believes that after so many successes, one is due for a failure. They believe it must average out in the short run. So that short run regularity and the law of averages both have to do with an issue of short run. So how do we tell the difference? The short run regularity says that, you flip 10 coins or you flip 6 coins or whatever. Each combination is equally likely. This one says basically that after a short amount of time, if you keep getting heads, then it has to be tails, but it's not likely because each time the coin doesn't remember, and so the coin's still a 50% chance, 50% heads or tails. So here's the example. If you got all those tails right in a row, many people would say, according to the law of averages, which isn't real, they believe that they're more likely to get a head on the next time, but still, like I said, 50% each time. People do this all the time in casinos. My mom does this when she goes on cruises or when she would go to Vegas. She would win, and if she got some money out of a slot machine, she would leave because she thought she got what she was due, and so it must be not very likely to win again next time. Another type of misunderstanding with probability is that some people just assume the risk is more greater in certain situations because they seem more scary. Many people won't fly because they think the probability of a plane crashing is high. You're much more likely to drive a car and get in a car wreck. Many of you probably have been in a car wreck, or your parents have been in a car wreck, but probably not too many of you have been in a plane wreck. So if you think about it that way, it's much more likely to be in a car wreck. People might say, oh, well, you're more likely to die in a plane wreck. Well, possibly. If the plane's going down and there's nowhere to land, yeah, you could probably die. But as far as the risk of of crashing being very, very great in a plane, is just not true. All right. So a lot of what your homework is going to be today is based on simulations. Now, we did simulations a while back. That's where you go to the back of the book and you get that random number table, or you can use random int on your calculator. And some of you had found some apps on your phone where you can do a random number generator. So you're going to be using this to do these types of examples. So anytime they say a simulation, that equals do random numbers. That's what that means, okay? So when we do a simulation, if we kind of have a basic idea of what we think the probability is going to be, we are going to assign random numbers from the table, or we're going to assign random numbers to represent like a success or failure, and then we keep going until we get a chance. So let me come over here, and we'll do a basic simulation, very, very easy, and then we'll do some more complex ones. So basically, flipping a coin, we know basically is 50% heads and 50% tails. We know that. So if I said to run a simulation, to see how likely it is to get 2 heads in a row. So basically we're going to just simulate 2 times, you know, pull 2 numbers and decide if it should be how likely it is to get 2 heads, and so that's what we're going to do. So first of all, you have to assign digits. Our random number table goes from 0 to 10. We remember that, right? Or 0 to 9, I should say. And so 50% of those numbers would be half of them. So I would say maybe 0 through 4 is heads, and 5 through 9 is going to be tails. Okay? So now I'm going to go to the back of the book where the random number table is. This starts on page T2. And it's going to be, let's use line 106. So just pulling from line 106, we have 6, 8. Okay, so 6 and 8 are both here, so that's tail, tail. Did I get 2 heads in a row here? No, so I'm going to put an X. The next 2 numbers in that line is 4, 1. Well, 4 and 1 both are between 0 and 4, so that is a head that time, and so that's a check. That's a success. Next one is 7, 3. 7 is a tails, 3 is a heads. We're looking for 2 heads. That's a fail. Then we have 5, 0. 5 is a tail, and 0 is a head, so it's another fail. 1, 3, both are heads again. That's another success. And we'll do one more simulation. 1, 5, that is a head, tail, so that's another failure. Once we've done our simulation, we're going to run it a certain number of times, and normally the book or the quiz or the test will tell you how many simulations we do. Right here I did 6 simulations because that's 1, 2, 3, 4, 5, and 6. The reason why I did 2 numbers at a time was because I was looking for 2 heads. So that may change. If I say what's the probability that I get 5 baskets shot, then you have to do 5 numbers at a time, and that would be 1 trial. And then you keep doing 5 numbers at a time. And then what you would do is you would say the probability. If you remember, probability is the number of successes over the number of trials. Okay, number of successes over number of trials. That number sign up top looks sad. And so our number of successes is the number of check marks. So if you do it the way I set it up, it makes it very easy to follow. We have 2 check marks, so that means I had 2 successes. The number of trials is how many trials I actually did. So we had 1, 2, 3, 4, 5, 6. So 2 out of 6, of course, is 1/3. And you could put this in your calculator, and you may know that it's 0.3 repeating. So if I move my decimal place 2 places to the right, it's about a 33% chance of getting 2 heads in a row. And this is not calculated probability. This is just called a simulation. If you know anything about probability, if you maybe studied it in Algebra 2 or another class, you could actually calculate the exact probability of how likely it is to get 2 heads in a row. But in our simulation, we got it 33% of the time, so we're going to go with that number for right now. Later on, we'll talk about the actual calculations. All right, here's another example. Shaquille O'Neal has an average of about 50% of free throw shots. What's the probability of him making at least 3 free throws in a row when shooting 10? So this time when you set it up, you're going to be pulling 10 random numbers at a time, and you're just trying to see if there were any 3 successes or more, and if there were out of that 10, you would put a check mark next to that line of 10, and if he did not get 3, then you would put an X. So once again, they use 0 through 5, or they have a 50% chance of making and 0% chance or 50% chance of missing. They're independent of each other. They assign 0 through 4 as a make and a 5 through 9 as a miss, and we would do that many times. So let me just give you an example of one trial of the Shaquille O'Neal problem. So I'm going to go with line 101 this time, just because it's easy to write that many numbers down. So the first 10 numbers are going to be straight from that table: 1, 9, 2, 2, 3, 9, 5, 0, 3, 4. And if you remember, 0 through 4 is a make, and 5 through 9 is a miss. Okay? So 1 is a make, 9 is a miss, 2 is a make, 3 is a make, or 2 is a make, 3, 9, 5, 0, 3, 4. So he actually made a lot of those shots. Did he make at least 3? Yes, we put one big check mark. Okay? The second trial, this is the next 10 numbers, are 0, 5, 7, 5, 6, 2, 8, 7, 1, 3. Make, miss, 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 miss. Make, miss, miss, make, make. Did he make at least 3? Yes, he made 4 that time. So as you're looking, if you have a 50% chance of making or missing and you're going to shoot 10 times, there's a very good chance that you're going to make at least 3. So we'll do one more trial here. This is the next set of 10. 9, 6, 4, 0, 9, 1, 2, 5, that's a 5, sorry, 3, 1, that's a miss, miss, make, miss, make, miss, make, and once again, definitely more than 3, okay? So the probability that he would get at least 3, we had 3 check marks out of 3 trials, which is 1, which is 100% in this particular trial. Now, if I told you to do more trials, you would have to keep going. And you can go on down to the next line. So when you run out of numbers in line 101, you just go on down to 102 and then 103 and whatever. But the key is to assign your numbers so that you're not skipping a whole lot of numbers, because I could have just signed 0 as make and 1 as miss. It's still 50%. But basically, I'd have to throw out every number that wasn't a 0 or 1, and that would just take forever. So just be careful as you assign digits. It's important to know that when we're doing probability theory to understand if something is independent or not. So you know what the word independence means. If somebody is independent of their parents, that means they are on their own and they do their own thing. They don't have to ask their parents permission. They don't have to eat what their parents are eating for dinner. They are independent. Same thing in statistics. If an event is independent of something, it just has nothing to do with the other event. So knowing the outcome of one does not change the probability for the other. For example, if I flip a coin and I get a head, does that change the probability of me rolling a 1 on a dice? No, it doesn't, because the coin and the dice are independent. They don't talk to each other. They don't know what each other's doing, and one doesn't change the other. So those are independent. However, if I flip a roll of dice and I look at the dice and you're trying to guess what I have, and I say guess which number, you could guess a number. But if I gave you a hint, okay, if I gave you a hint and I said, oh, it's an even number, are those events independent? They're not, because once you know that I have an even number, then you know you can only guess 2, 4, or 6 if you want to be right. And so that changes the probability of you getting it correct. So something like that is called not independent or dependent. All right, so we're going to practice assigning digits because that's one of the key elements of here. Once you know how to assign digits, it's really easy to go to the back of the book and get the random numbers and figure out what is what. So the first example is we know 80% of families have internet connection, and I'm sure that's old data, but how would you assign digits for those who have internet and those who do not? Remember, the back of the book tends to use the numbers 0 through 9 because then they just repeat, or you could combine and make like 10 or 12 or whatever. So if you can use 0 through 9, that's great. Or you might use 00 through 99 or some number in there to help you out. So if I know that 80% of the families have internet, that basically means 8 numbers will be internet, and 2 numbers, because 8 plus 2 would be 100, would not be internet. All right, so let's assign digits. I like to start with 0. And I wouldn't say 0 through 8, because if I count 0 through 8, that's actually 9 numbers. I have to go down 1, so 0 through 7. And if you don't believe me, 0, 1, 2, 3, 4, 5, 6, 7, that was 8 numbers right there. And then over here in the non-internet side, I could say 8 and 9 would represent not getting internet. So that is how you assign digits for the first one. The second one, 65% of people have 2 or more computers in their home. So if they have 65 that have 2 or more, how many have less than 2? Well, they have to add up to 100, so 65, 75, 85, 95, that means 35% have to have less than 2. This is a little bit harder because we can't assign decimals, so I'm going to use random numbers again. Okay, and I'm going to go with the bigger numbers, 00 through 99. So 00 through 64, we always go down 1 because 00 counts as one number, will be those who have 2 or more computers. And then from here, after 64 is 65, and we could go all the way up to 99. And this would represent 1 or less. So that's how you would assign digits for the second one. You can also assign digits for more than just 2 categories. So if we had a bag of candy and 20% is red, 50% is blue, and 30% is green, we're going to assign digits. If there are multiples of 10, I tend to use 0 through 9 as my assigning. If they're an odd number, like it's not, or I guess it's not a multiple of 10, so 61, 62, anything that ends in anything other than 0, I'm going to use the 00 through 99 assigning of digits, because it's just easier to make them weird numbers like that. All right, so 20% basically means that 2 numbers are going to represent red. So maybe 0 and 1 can represent red. 50% means 5 numbers represent blue. So I just pick the next 5. So after 1, there is 2, 3, 4, 5, and 6. So that's 50% of the numbers. And 30% means 3 numbers. So after 6 comes 7, 8, and 9. And that takes up all my digits. And so now we can run a simulation. Okay? Now, something you should be careful of when you're assigning digits is you cannot repeat. I can't say 0, 1 is red and then start back over here and put a 1 here on blue, because how can a 1 be a red and a blue? It can't. So you have to be super careful that your numbers don't overlap. Same thing up here when you're dealing with 00 through 99. You want to be super careful that none of those overlap again. All right, let's do a couple more examples. All right, here is our example. Alright, so here's my example for you. In a game of chance, a player wins approximately 1/5 of the time. We're going to run a simulation to see how often we win if we play 3 times. And we're going to do maybe 5 trials this time. So as you do a problem like this, I'm going to kind of talk about what I want as you're doing these. First of all, you always have to assign digits first. And so I'll just say assign digits. 1/5 is approximately, or is exactly 20%. So 20% of the time somebody is actually winning. So anytime they give you a fraction, you have to change it to a percent so you know what to do. So if you win, 20%, remember, is a number that ends in 0, so we can use between 0 and 9. And so 20% means 2 numbers. So 0 and 1 could represent a win. So if you win 20% of the time, how often are you going to lose? Should be 80% of the time. Not too great of odds. But we have 2 through 9, which will represent losing. Next, you have to tell me what exactly you're doing to get your random number table. If you are using a calculator app, or an app, you need to just say that right here. You're going to say using random int or using an app. I'm going to say, since I'm using the table, I'm going to tell you what line I'm using. And so maybe this time I'll use line 111. Okay? And it wants us to play 3 times each trial and a total of 5 times. So that means I'm going to pull 3 numbers at a time and then either say if I win or lost by putting a big check or an X. And then I have to do that a total of 5 times. Okay, so from line 111, the first 3 numbers are 814. 8 is a miss, 1 is a make, 4 is a miss. Did I make 1? Yes. So there we go. The next 3 numbers are 868. All of those are in my lose category. That's trial number 2. Next one are 948. All of those are in the lose category, so that was my 3rd trial. Next is 760. Well, 0 is a make, so that means I got at least 1. 513. I have another make. And then 092. Well, 1, 2, 3, 4. Oh, I actually did 5 already. I was trying to do too much work. All right, so my probability, that would be the next thing you would state. Well, I did 3 check marks out of 5 trials. So 3 out of 5 is 20, 40, 60% chance of winning one time if I play 3 times. Okay? You might notice that that's different than the 20% I started with, which should make sense because I'm trying 3 times, not 1. This is if I had 1 trial, I might only get 20%. All right, one more example. And then after this example, I'm going to get you started on the last assignment on the homework because that one's a little bit different. Okay, so here's example again. This time what we're going to be looking at is maybe a 25% chance of rain in a certain area, and somebody is going to be going on vacation there, and so we are interested 25% chance of rain in a certain area. So we're going to assume that this area is magical and it always is 25% chance of rain every day and it never changes because it has to be independent. So we're going to assume that. We're wanting to know if 2 or more days will have rain out of 6 days. So maybe you're booking a vacation there and you're going to stay there 6 days and you got maybe 2 rainy day activities you could do, but most of the time you want to be outside, so you're hoping that it doesn't rain. And so we're going to do 4 trials. This number does not end in 0, so I need to do the 0, 0 through 99. If 25% is rain, that means that 75% is clear. And signing digits, rain. Remember, you always go down 1 than the number that was here. So it's 0, 0 through 24. And the chance that it's clear is going to be 25, because that's the next number, through 99. Okay, I'm using a table again, and I'm going to look at line 136. And it wants me to look at 6 days at a time for a total of 4 trials. So I'm going to have 6 numbers at a time until I have 4 rows. Okay, so the first 6 numbers in line 136 are 0, 0. No, I'm sorry, that's not. And actually, the first pairs of numbers, remember you have to look at 2 at a time. So we have 0, 8, 4, 2, 1. That's 1, 2, 3, 4. 4, 4, 7. 5, 3. 1, 2, 3, 4, 5. I need one more. 77. All right. So these are more than 6 numbers because remember we need 2 numbers at a time because of how we assign digits. So 0, 8 is a rainy day. 42 is a clear day. 14 is a rainy day. 47 is clear. 53 is clear. And 77 is clear. My question is if we have 2 or more rainy days. We got 2 rainy days here. That is a success, even though we don't really want rain. All right. The next set of numbers, 28, 74, 47, 55, 92, and 08. 28 is clear, 74 clear, 47 clear, 55 clear, 92 clear, 08 one rainy day. We did not get 2 or more rainy days there, so it's an X. All right, next one. 56, 37, 91, 40, 92, and 45. So that is a clear day, 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 a clear day. We had no rain whatsoever. That's an X. All right, this is the last number on line 136, and that number is a 4. And so now I have to hop down to line 137, and the next number is a 5, so that makes 45. And we have 36, 45, 66, 81, and 26. All right, that is clear, 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 because none of those numbers were between 0 and 24. So that's another day where we did not have 2 or more rainy days. All right, so we had 6 days that we were testing each time, and we have 4 trials. That's trial 1, 2, 3, and 4. That's our 4 trials. We had 1 day that had, or 1 week that had 2 or more rainy days. So that is 1 out of 4 trials, or 25% chance, which is kind of crazy because that's actually the 25% chance we started with. All right, so that is how you set those up. Please be careful with these numbers. The 2 or more days is just letting you know what a success is. So at no point was I looking for the number 2 or anything like that. It was just how many check marks I had to have or more. Always go back to these numbers to decide if you got a check or an X down here. And then also, if you are still rusty on using the random number table and you have to use the random number table, make sure you rewatch this video and kind of go slowly and look up the line number each time as I say it, and follow along in your book and see if you see where I'm getting these numbers from. Because really I'm just going straight across, and you know the numbers are set up in sets of 5, but I just go ahead and pull the next number. Like here it was 08421, and then there was a space in your book, and then the 447, but I'm looking at 2 numbers at a time, so even though there was a space in the book, I just pulled those 2 numbers together to equal 1. All right, once again, remember, if it ends in anything other than 0, you're going to assign your digits 00 through 99. You always bring it down 1 less than the percent they told you, because you're going to start with 00. If it is a number or a percent chance that ends in 0, you can just do 0 through 9. It makes it a little bit easier to pull 1 number at a time. All right, your homework is going to be 325, numbers 14 and 18, and then on the next page, numbers 19, 20, 21, 22, and 24. So these numbers right here, 19 through 22, is not actually doing the... Actually, don't do 22. I don't want you to do 22. So let me tell you what I do want you to do. We're going to do 14, 18, 19, 20, 21, and then skip down to 24. So don't do 22. All right, so these right here are questions where you're basically going to tell me something about a definition, or something like which error is being told about. Remember, we had the different names of errors that people assume, like the law of averages and all that stuff. On the first page, 14 is a simulation, so you're going to use the random number tables. And please write out each step. Please tell me what a success is and what a failure is, or like what your numbers are assigned as. Tell me if you're using a calculator or if you're using the random table. List the numbers out. You can't just tell me the results. You actually have to type out on your homework, 1, 3, 6, 6, 2. Like, this needs to be on your homework. You can't just tell me, oh, I got all of those correct, or I got all of these successes, because the only way I can grade when you have a random number table or a calculator that I can't see is you actually list the numbers, and I can compare it to how you assigned it to make sure you're doing it right. So you will lose all points if you don't list the numbers from your table or your calculator. So list all numbers. And you can say, well, what if I just tell you I'm using line 106? Yes, you still have to write all numbers. So please make sure you know that that is what I'm looking for. Exactly how I wrote it out on this whiteboard is what I'm expecting to see from you on your homework. That's why I wrote it out that way. After you do your assignment of digits, you can put checks or X's and O's, however you want to signify what's what. You do the proper number of simulations. And then at the very end, you tell me the probability. All right, so for number 14, they tell you to do it 25 repetitions. That would take forever. Just do 5 repetitions. I cannot write on this thing today. Pretend that says repetitions. 18. It says to simulate 20 repetitions. Let's not do that. Let's do 10 repetitions this time, and 5 repetitions on number 14. And then number 24, you're going to simulate many responses again, and this time do 10 trials. On this one, on number 24, this is one I want to speak to you about. It's saying that you're going to play a game, and it says you either, I'll either pay you $2, so that means you'll get plus $2, or if you lose, you owe that person $1, so you have to do a -1. So when you're doing your simulations and you get your numbers, instead of putting a check or a minus after you've done it, you need to decide if your partner won and you have to put a -1, or after a trial maybe you win and so you get $2. And after your 10 trials, you're going to keep track of like how many times you win or you lose, that kind of thing. And at the very, very end, what you're going to do after 10, because you have to do 10 trials, you're going to count up how much money you would have won. And you can do this on a calculator, or you can do it in your head, I don't care. So -1 plus 2 is 1, 1 minus 1 is 0, 0 minus 1 is -1, -1 plus 2 is 1. So if I would have played this game 5 times, and these were my outcomes, I would have came out ahead just $1, because, you know, I owed him some and he owed me some, and so that's how much I won after 10 games. So when you do your simulation for number 24, you're going to have 10 trials. So you're going to have 10 numbers over here of either -1 or 2, and you'll add them up and see how much money either you win or you lose when you play the game. Alright, so I think you're going to be well set for your homework. There's no surprises. 14 and 18 are simulations, 24 is a simulation, and the only difference is 24 had this instead of checks, and so I wanted to help you out to make sure you understood that. So once again, you can comment on the comment section if you have questions, but I think it's going to be pretty easy. The only issues are if you don't remember how to assign digits, you need to review that. You can also go back to my webpage and look back up the PowerPoints from when we started doing random numbers a long, long time ago if you've forgotten how to do that, or maybe refer back to your notes if you still have them.